Alright children, I welcome back you again for our physics weekly class. Now, as you all know, we are doing a chapter called Laws of Motion, isn't it? Chapter number 3, we have completed Unit A, Contact and Non-Contact Forces, Unit B, Newton's first law of motion, Unit 3, Newton's second law of motion. Today we are starting Unit D, Newton's third law of motion. This law is the easiest law from or among the three laws of motion. Newton's third law of motion. So now I request all of you to pause this video right now and open your book to this page. Okay, my page is 68, but it may not vary because I have an old book, so a new book may have a different page number. So please accordingly you find this, go to this Unit D and along with the pencil. So whenever I ask you to underline, you please take a note to underline the sentences I ask you all. Alright, so Newton's third law of motion. Let's begin. Newton's first law tells us about that to bring a change in a state of rest or in a state of motion and of an object, a force is needed. That is, force produces change in velocity of the object. That was what we learned in the first law. Then in the Newton's second law, we got that magnitude of acceleration produced by a force when applied on an object, isn't it? So here we learned these two laws. In the first law, force is needed to change the state of rest or state of motion. Second law, we learned that the rate of change of linear momentum is directly proportional to the applied force. But we do not know, these two laws does not explain, okay, how does the force acts on object. So we have just learned that the force is acting on the body, and this force is what, bringing some change on the body, but we do not know how the force is acting on the body and how does the body react when the force is acting on it. So this is explained by Newton's third law, and this states that please underline this, every action there is always an equal and opposite reaction. So whenever there is action, okay, you always get reaction of it. So you know, whenever you have doing some action, that action always produces reaction. Action bhayera chai ke huncha, reaction huncha. Alright, so for example, consider a book lying on a table. The weight of the book acts vertically downward. You know, weight of an object always acts in the downward direction because weight is the force by which earth is pulling it. So when earth is pulling something towards it, it's always in the downward direction, isn't it? But the book does not move downward. It implies that the resultant force on the body is zero, which is possible only if the table is exerting an equal force on the upward. So the force on the book equal to the weight of the book. This force on the book balances the weight of the book. So you see that there is a table. On the table you have placed a book. So thus this book, because of its weight, it will be pointing, or force acting on it due to its own weight will be in the downward direction. But you see that because of the table, the book does not go towards the earth, that is, it does not fall down. Instead, what happens, it is remaining at rest on the table. So it means that table is pushing it a force in the upward direction. So here you see that the action is due to the weight of the book, which is in the downward direction, but because of this action, the table is also pushing the book in the upward direction. That is normal reaction force, the one that we have learned, isn't it, in the earlier chapter, right? Contact force we have learned this. One of the contact force is normal reaction force. So here normal reaction force is acting in the upward direction, which means this is a reaction force. So to every action there is an equal and opposite reaction. So here you see that the action done by the weight of the book in the downward direction is producing a reaction force which is in the upward direction due to the table. Alright, so similarly, let's go to the next example. While moving on the ground, we exert a force by our feet to push the ground backward. हामी हिँड्दाखेरि चाहिँ हाम्रो खुट्टाले चाहिँ भुइँलाई चाहिँ ठेल्दै गरेको हुन्छ. In which direction? Backward direction. So पछाडि ठेल्छ, we are able to walk in the forward direction. So our feet, okay, is pushing the ground in the backward direction, which is the action. यो चाहिँ भयो action. You can write here action. Okay, and because of that the ground pushes us forward. This is the reaction. So you see, action is making and producing reaction. So this is our Newton's third law. Okay, so whatever the explanation I gave you here, it's explained here. You can just go through it. Okay, in the above stated examples, here you can see we observe that there are two objects and two forces. In the first example, the weight of the book acting on the table downward is the force of action, whatever I said you here, isn't it? And the force exerted by the table on the book, that is in the upward, is the reaction. I told you, normal reaction force, isn't it? And in the second example, the force exerted by our feet on the ground is the force of action, and the force exerted by ground on our feet is the reaction. So I have asked you to write circle and write the action and reaction here. Okay, so please write with the pencil. Okay, now let's go to the second page, next page of this this unit number D. So thus, Newton's third law of motion, it states, in an interaction of two bodies A and B, the magnitude of reaction, that is the force AB, applied on the body by B on the body A is equal to the magnitude of action, that is force BA, applied by the body A on the body B. Okay, but they are in direction opposite to each other. So don't get confused here. You just see that action, okay, action produces, or because of action there is reaction, and you must, okay, you must see that action, okay, let me rewrite again here. Okay, action makes birth of reaction. Now what this entire paragraph here with the one which you have in the box is trying to say is that action and reaction, they are opposite to each other. If action is in the downward direction, reaction will be in the upward direction. Okay, if the action is from left to right, reaction will be from right to left. Opposite हुन्छ एकअर्कामा, त्यति मात्रै भन्नु खोजेको. Okay, so Newton's third law says that to every action there is equal and opposite reaction. Now there is a small note here, please underline this. The action and reaction never acts on the same body. See, very important thing to remember here. The table र बुकको के थियो, एक्सन चाहिँ बुकले गराउँदै थियो, रियाक्सन चाहिँ टेबलले दिँदै थियो. हिँड्दाखेरि action चाहिँ खुट्टाले दिँदै थियो, reaction चाहिँ भुइँले दिँदै थियो, the ground, isn't it? So here you see that action and reaction are never acting on the same body. Action एउटा बडीमा छ भने reaction will be on the other body. Okay, but they always act simultaneously. भनेको चाहिँ सँगसँगै एक्ट गर्छ. Okay, action र reaction सँगै, they work together simultaneously, भइहाल्छ. Okay, on the two different bodies, that is the force of interaction are always present in pair. जहिले पनि पेयरमा हुन्छ. Understand? So please remember this. Now there are some experiments. You just go through this experiment. That is your homework. Now examples of action and reaction. Let's see. A book on a table. Okay. So I have explained you just now. Pushing a wall. When you try to push the wall, you exert a force on the wall. That is your action. Okay. By pushing the palm of your hand against it, you experience a force, that is reaction exerted by the wall on your palm. So you try to push the wall. So when you try to push the wall with your palm, you will feel that as if the wall is also pushing you back. So the action done by your palm produces a reaction force by the wall on your hand. So this is an example of action and reaction. Alright. Now the other one, number third example, is motion of a boat away from the shore. When a boatman wants to move the boat away from the shore, he pushes the shore by a bamboo or with his oar. That is the action. Okay, the shore pushes the boatman along with the boat away. With equal and opposite force, that is the reaction. So when the boatman is trying to move the boat away from the shore, okay, side border टाढो लान चाहन्छ भने चाहिँ he places a bamboo. Bambooले चाहिँ उसले त्यो भित्तालाई ठेलेको जस्तो गर्छ. Okay, river bank लाई ठेलेको जस्तो गर्छ. So that is his action, and the river bank pushes the boat. That is the reaction. All right. Number fourth example is motion of a boat in water. It's exactly the same as in number three. Now another one, interesting one, firing a bullet from a gun. So when the bullet is fired from the gun, what is happening? The force is pushing the bullet in the forward direction. So that is the action. What is that? Action. But there is a recoil. Gun चाहिँ अलिकति पिछाडी move भएको जस्तो हुन्छ. That is called recoil of the gun. So that is the reaction. So here you see action is on the bullet, reaction is on the gun, acting on two different bodies, but they are acting together simultaneously in the pair. So whenever you are applying Newton's third law, you have to apply in such a way that there is always a pair of forces. Means action force and the reaction force. Similarly, the rocket motion, how does the rocket goes up, flies up? Isn't it? In Diwali, you might have busted the crackers and a rocket bomb. So rocket goes up when you light it, isn't it? So how does that happen? In a rocket, fuel is burnt inside the rocket. The burnt gases at a high pressure and high temperature are expelled out of the rocket through a nozzle. Understand? So when the high pressure gas is coming out of the nozzle with a force, that exerts the action on the gas, and that is why what happens? Because of that, it pushes the rocket. It pushes the rocket in the opposite direction. That is the reaction force. That is why, okay, here you see that the gases are coming out from the nozzle of a rocket in the downward direction. That is the action. And because of this action, the rocket is pushed upward. That is the reaction. So gas चाहिँ निस्किँदा ओह्रालो निस्किँदैछ, त्यसले चाहिँ ओह्रालो जाँदाखेरि चाहिँ त्यसले रकेटलाई त कता ठेल्दैछ, उकालो ठेल्दैछ. So that is the reaction. So again here you see that there is a pair of force acting on the object. All right. Okay. Now let's go to the last page of this unit. In this last page we have 3 more examples. Number 7th example, motion of a man on a ground, like walking. I've already explained you this, isn't it? Whenever a man is or you are walking, you apply force by your feet on the ground. खुट्टाले तिमीले भुइँलाई ठेल्छौ नि त. That's why you are able to move forward. So here the action is by your feet, which is in the backward direction. अब यसको opposite, backward to opposite is forward, isn't it? So the ground exerts. Please underline this. If you are not able to see this, let me make let me zoom it. Okay. Where did it go? Okay, so here I have, okay, sorry, I guess I cannot zoom it. Anyways, okay, you just follow the book also. So here, okay, what is happening? The ground is exerting an equal and opposite force. That is the reaction. So that is why you are able to move forward. Are you getting my point? So you are pushing the ground by your feet in the backward, which is making you to move in the forward because the ground pushes you in the forward direction. So your foot is acting, applying the force, that is action, and the ground is applying the force on you, that is the reaction. All right. Similarly, you have another example, motion of a boat away from the shore while stepping down. It's exactly the same one as earlier, so you can just go through it. And catching a ball. Whenever you are catching a ball, how do you catch? When a ball comes to you, you hold the ball and your hand moves a little bit along with the ball, isn't it? So whenever you are trying to catch a ball, the ball exerts a force on the hand. Ball तिम्रो हातमा ठोकिन्छ, ठोकिँदाखेरि चाहिँ you feel some force on your palm. That is the action. Okay, and the cricketer exerts, that is you try to catch it with your hands with a force. So that is the reaction force. So here you see action and reaction are acting together simultaneously in a pair. All right. So this was your Newton's third law. Now your homework. I will be giving the notes or answers of this question number 2 and question number 4 ko 1, 3 and A, B and C. Your homework will be to do 4D, 4E and 4F, okay, from your exercise number 3D. All right. So that's all for today. Thank you.